So hello everybody, and thank you for being here. I hope you will still enjoy my talk after the lunch, which is always challenging to keep people energized, but I try to do my best for that. Let me see how this clicker works. Agreement, simple. Yeah, so I've been asked to say something about the circular supply chain, and I want to address one of the biggest supply chains in the world, which is the wider built environment. And that's very much key to everything we do in daily life. We live, we work, we transport ourselves, and my company is very much tasked to shape a better world in our living environment. So I thought it would be interesting to look to this kind of supply chain and then try to make some connections to the steel industry. I'm always staggered by this number, which says that Europeans only need between 2 and 3 planets worth of resources to sustain their current and lifestyles. And that's only Europe, you know, so we are already overutilizing the planet. And I'm not an idealist, but a realist, and I know that cannot go on in that way. And what we also see, and the awareness is there, rapidly growing, that is directly endangering the growth of even continuities of economies. And knowing this and the fact that we do a poor job in reusing materials should make us rethink how we produce, live, consume, travel, etc. And find a way how we can maintain our wealth, so to say, or perhaps grow it in average, but not by overutilizing the planet. And that's a big stretch, I can tell you. So for me, the circular economy is not a solution on itself, neither is cradle to cradle. But they are very interesting concepts that help us find a more systemic approach to challenge doing a better thing in how we produce, how we live, etc. And in this case, growing towards a regenerative and restorative solutions for, in my case, urban environment and living. For others, it may be another topic. And for me, there's a fundamental difference between circularity and circular economy. Whereas circular economy, in my view, is very much focusing, and sometimes too narrow focus, on looping materials, circular economy addresses also the economic need for that. And there may be a simple litmus test to test if something is circular, and this is an interesting one. So it is not only, although very important, to decouple material use from economic growth, but it's also, it should be profitable for business, has been stated today earlier. And it should also contribute to a wider economy. And that's quite difficult to address. So not only about the idea of better materials, of less poisonous material, but also how does it contribute to employment, to alleviating poverty, and also not to forget, minimizing the negative externalities from everything we do. And we tend to focus on our narrow, rubber-banded business models, but how does it actually, how do we perform outside these boundaries? And to be successful in the transition to a linear economy, we need to make a real step change. And that approach should really help us in doing things differently, rethinking almost everything we do at every step in our processes, and apply those principles, and there can be many frameworks for that, to every aspect, in my case, of the built environment. And in general, it can be said that we try to keep materials and components not only in the loop, but at their highest value. And I haven't heard that very much today, but when we talk about recycling or having hybrid materials, and also the steel example of Michael, where he talked about a lot of copper and steel, it is recycled, but not at its highest value. And that's a big challenge. And really, recycling is the last resort. So if you look to the steel industry, it has an estimating recycling rate of 90%. And it has made great efforts to avoid that used steel gets lost, you know. But against the circular economy concept, there's lots to gain, especially considering the fact that global steel consumption is still growing at an incredible high pace. So yes, we can focus on reusing the material already in the loops, but we still need enormous amounts of virgin ore, so to say, so virgin materials. And there's a big challenge because that's not only about recycling, but also trying to reduce that. So looking to the world I'm living and working in, and what we all do, it is safe to say that the current global construction industry is really addicted to steel. So 65% of all steel and aluminium, take that into the equation, is applied into the steel industry, which is a big amount. So we are a heavy user of everything you produce. And the reality is that the construction industry is really slow in adapting and to change. And I'm looking also to my own colleagues. And this has some reasons, of course, but apart from the fact that it's really, it has a lot of mass to produce, it's also very expensive. We're still building on a daily basis only prototypes. Which industry does this? We only build tailor-made buildings, for example. We have a lot of split incentives. So if you look to the whole supply chain in the built environment, it's all transactional. And the former part of the chain wants to earn money at the other one, rather than looking to common incentives and looking to mutual gains. And if it comes to innovation, for example, it's really difficult to scale up because we have a lot of write-offs then to make on existing investments in machinery and production methods, etc. So if I talk about built environment and the steel industry, we need each other to do a better job in how we deal with our material resources. As said, steel is almost a closed-loop material, but also to put some relativism to the numbers I heard today, even with it's also mentioned on the sheet, an assumption of a fairly infeasible assumption of 100% carbon capture, we still have 43 efficiency gains to meet, and we need to achieve much more effectiveness through different and smarter design. And this is based on recent research that we've developed together with ARUP, and this is from the UK perspective, but it will be pretty much also comparable to other places. So if we look to what is then needed, we should go beyond what optimizing, as we said earlier. And we should also think about how we can influence making the right decision. So I'm not going to talk to you about all kinds of solutions, although I will demonstrate some of them later on. But there's also who do we have to influence to get us on the right side of the table. And I came across this research of only 8 years ago, or 6 years ago even, which was developed, and it says something about where are decisions being made, at what timing, if it comes to materialization of buildings in this case. And what it shows that the most decisions are being made in an early stage, very early stage. And most of the time, the imperatives for these choices are design and functionality. And 5-6 years ago, you see on the right bottom side this little graph with bars, you see the green ones. They were all kind of influences on decision making to certain materials, and they were virtually not important. Much more important were costs, and much more important were availability and ease of use. But it was also found that clients and investors regularly have a very significant influence on these decisions on materials. So in this early stage when decisions are being made, later on nothing changes very much. So we have to go upstream and look to the decision makers. And what we now seen, that this has shifted from looking to lowest prices, etc., that sustainability become much more imperative for investors. So, for example, the larger investors in real estate and also the asset managers like BlackRock, they're all revisiting their ESG KPIs, the environmental, sustainability, and governance KPIs, because they know how a bad investment looks like nowadays. We can assess that, but really don't have an answer. What is a good investment? And in a good investment is also having a clear view how the assets they own should behave in future, or how they relate to all kinds of topics we are discussing around circular economy. What is also interesting, around the same time that this report was being published, we also had a publication of the first publication from the Ellen MacArthur Foundation called An Economic and Business Rationale for an Accelerated Transition. And to be honest, to give a lot of credit to the Ellen MacArthur Foundation, they made it happen that on a lot of tables of decision makers of national and international governments, the larger corporates and enterprises, circular economy is really on the agenda. So it's not a matter if it's going to play a role for all industries, including steel industries, but also in what way. So a typical way to transition from a circular economy to a circular economy from a linear economy is by applying all these leverages, as you can read in one of the publications of Ellen MacArthur Foundation, to every aspect of the built environment, from the whole system, like a city, to the individual components. You may also deliver some of them. And we, as ARUP, are very serious about the circular economy, because we think that leadership is needed also in our industry to really change how we produce, how we design, how we operate our buildings. And our journey started about 4 years ago, ahead of the London Design Festival, where we said, okay, suppose we take a very recognizable asset like a house, and suppose that we really try to apply all principles to the letter on just building a house. How does the development and the usage of a house look differently? And actually it challenged us very much. So we used this not only as a kind of asset which was nice to show, but also we took it as a learning journey for ARUP, and we initiated a lot of research because we knew more what we didn't know. There was more that we didn't know than we knew. And this made also us aware that we really need to rethink the way how designers behave and relate to circular economy. This project started actually by asking ourselves 4 basic questions, and they may be also be metaphorical for the steel industry. The first thing is, being builders and being designers of new buildings, do we need to build at all? Hence challenge our business models for aiming for volume, but not building is the best way to go forward, we would say. The second thing, can we build more cleverly, or can we build less? And the fourth one was about, can we build more efficiently? And this was very helpful in rethinking not only how we design, but also how we should relate to our partners in the whole value chain. An interesting takeaway was that we had a supplier of steel beams who said to me, well, I'm happy to contribute to this project, and you see the steel beams also in this house. I said, that's great, but you know, you're not a supplier, but you're now the owner of the steel bar, and we want you to keep that ownership. And they said, you know, we are a supplier, we are not a take-backer. But that's a very interesting takeaway, because it means apparently that once they supplied these steel beams, it was not of their value, for them of value. And we need to go back to a paradigm that the supplier says, okay, I deliver something, and it keeps its value at its highest functionality. So the example of the spiral springs in the mattresses of Oping, I think it was, is really interesting. This industry needs to recognize that they deliver really good products, and actually they cannot sell it only once, but they can sell it 2, 3, or 4 times, and there's the business imperative. So rethinking how you relate and what you're going to apply is very important. So let me demonstrate some different angles from design perspective to rethink design and resulting in solutions for concepts such as designing waste out, or new technologies to be applied in our industry, or ways to avoid hybrid constructions, which is very difficult if you want to reuse your materials or your products, and new business concepts. And some may be directly linked to your industry, and some may be as an inspiration. So what you see here, I hope it will run. If not, I'm going to, no, sorry. So what you see here is actually a snapshot of a footage material, but it doesn't run, of a 3D printed steel bridge for pedestrians. The challenge was not just printing a bridge in steel, which was, by the way, a challenge on itself. But what we try to do is also, suppose we have this production method as a repertoire, how can we reduce material usage to the maximum? So what we did, we applied so-called parametric design to rethink how actually this bridge should look like. And it was a very much free-flow form with all kinds of strange things, and nobody would invent a bridge that way. But being able to develop such a bridge was also by joining up all kinds of partners in the whole supply chain that normally wouldn't work together. Of course, we have digital and robotization, and we have, of course, the welding industry and the steel industry, in this case, finding the right kind of steel to be used. But very much also the designers had to rethink all the practices, how they should build such a bridge. This is about off-site manufacturing, but this is also about avoiding transport of materials, because you can simply send a file to the other end of the world and you can make the same bridge. Actually, this is also being applied nowadays in automotive industry, where spare parts are not being taken into stock, but they can be 3D printed, especially when it comes to certain kind of plastics. This is very interesting. You don't have stock, you don't have storage of old components, you have always the most up-to-date replacements components. So in this simple case of 3D printing a steel bridge, we had new business models, we had collaboration, we were thinking how can we earn money with this kind of production, because it also takes away some parts of the supply chain, and it's also about, okay, what are we going to do afterwards? And by the way, this bridge was about 40 or 60% lighter than an average steel bridge. This is an example of trying to define a new design paradigm by reducing the number of tailored components. And I'm sure that if you look to the average table of your steel components, like beams, etc., you have unlimited number of options for using every beam you need as a designer. For design, from a design perspective, we reversed this and we said, suppose we have only one component, can we build a whole building out of that? And what can we do to make the joints in such a way that they're completely reversible? This has been done with wood, but similarly it can also be done with other materials. And this reversible perfection meant also that we can take away the materials at the original value, and they can be reused and reused again. So actually this is a very simple example where we use these kind of constructions, or we want to apply this kind of construction in temporary venues, for example. And then one of the examples of these temporary venues is the People's Pavilion at the Dutch Design Week in Eindhoven last year, together with Overtraders W and SLA in architecture. And actually this won many international prizes. And the metaphor was here, can we develop a venue and we return it back to sender? And actually we did. We borrowed all the materials from either the city, from suppliers, and they took it back and they had to demonstrate to us they reused it again for new purposes. And this is a metaphorical for delivering products or materials as a service. Or this is about new kind of ownerships, because as a supplier you used to sell stuff and then you get revenues from that, and that's very good for your balance sheet. But what does it mean for you as a supplier that you keep the materials on your balance sheet? Accountants won't like that, because then at a certain moment it can become a different liability, different responsibilities. So what we need to do in these kind of situations, and there we talk with a lot of developers, but also with suppliers of products and materials, is, okay, what do you need to safely keep ownership of these products, but that we can sell them as or hire them actually as a service, and it also makes a good business case for me as a developer or an end user. So look to the mutual gains throughout all the aspects of the whole supply chain, and not only for one cycle, but for multiple life cycles. A very promising technology is about, I mentioned earlier, parametric design. What you see here is one design competition with a whole consortium, where we try to find simplicity in a very complex geometry, because you see on the left bottom side, you see how the building really looks like. But what's the optimum if you're developing such a complex building? And rather than looking at 3 scenarios, which we normally do in our business, we develop scenarios which we call 1,000 same, but different kind of scenarios, optimizing not only functionalities such as sun shading, square meters usage, but also material usage, standardization of components, etc., etc. Again, if such a building is being built, we need all kinds of parties in the whole supply chain, including those who deliver these enormous amounts of steel, for example, to see, okay, what is the optimum standardization, and what can we do, how can we develop and design and construct this building in a way that in future it can be reused or reclaimed, or that even this building functions as a donor for new buildings with their materials. And finally, and then I close off, I want to say something about this part, but I know we have a speaker for this. But I want to address the relevance of the concept of buildings as material banks. We all talk about reusage, but if you look to steel beams in buildings, it's relatively easy to find where are steel buildings, but we don't know what the quality is of these beams. And as structural engineer, you may know, for those who are in the room, that one steel beam is not the other, or one concrete beam is not another, or all the materials in there. So what one of the founders of this great initiative called Madaster, this foundation, said, waste is material without an identity. So if I ask you, as a steel supplier or supplier of steel components or delivering to certain industries, how can we track and trace your materials where they are? All kinds of things are being challenged as how can we track and trace the materials? How do we unlock this value? And what is needed if we apply it to keep that value at its highest level in its own system where it sits before we go into the next stages such as recycling. So this means a change of role, and having access to this kind of information is so relevant because then it becomes a very interesting repertoire for designers, for construction firms, but also for clients who then can say, okay, I want to have my building built out of an X amount of reclaimed materials or reused materials. And we contribute in this way also to all other kind of objectives. Thank you very much.